Now we're going to look at just simplifying some radicals without any operations. So if we look at the cubed root of 104, we need to focus on the index that we have. We're used to working with square roots. Now we've got some cubed or fourth or fifth or sixth root. So the cubed root determines what we're looking for within that value underneath our radical. So if we're breaking down 104, we need to either see if 104 is divisible by any of those perfect cubes and pull them out, or we factor it out and find the groups of 3 because those would resemble a perfect cube. So I know that 104 is even, so we can start with 52 and 2. 52, 26, 26, 13 and 2, and then 13 is prime. So we've got a group of 3 2's, so that group or that perfect cube still comes out front, and then we've got the cubed root of 13 left. And that's all there is. So as long as there's no perfect roots underneath that radical in there, then you guys are good to go. So let's look at the ones down here. So number 10, fourth root of 625 times z to the 12th. So we could factor out, you always want to check too, and since I'm saying this, it's probably a good chance that it is the case. Check to see if the values you have in that radical are a perfect root. So actually, the fourth root of 625 is just 5. So that part will come outside. The fourth root of 625 is 5. You could rewrite that as 5 times 5 times 5 times 5. Right there, is your group of 4 5s. So then the next thing we have to look at is your z to the 12th. So how many times does 4 go into 12? 12 divided by 4. Well, that's also a perfect value. It's just 3. So if there's nothing left over, that's fine. You just won't have a radical left. And that is okay. So the fourth root of 625 z to the 12th is simply 5z cubed. And again, you guys could write out 12 z's and circle your groups. That's fine. It's just a little easier to be able to know how many times that index goes into your exponent and what you have or don't have left. So if you look at number 11, you can't find the sixth root, or you can't find the cubed root of 6 at all. So we don't have to worry about that. So that means we are definitely going to have something left under there because the 6 has to stay under that index or under that radical. So now we need to look at all of our variables. So 3 goes into 4 how many times? Once, right? 4 divided by 3 is 1 and 1 left. So that means there will be one little guy left under our radical. And then 3 into 9, or 9 divided by 3. That's a perfect value also, divides evenly. And then 3 into 14. 3 goes into 14 4 times. It's 12, which means there would be 2 guys left underneath the radical, but we're going to have z to the 4th outside. And again, you don't have to write that power of 1 or that exponent of 1 if you guys don't want to. It does not matter, but it is not wrong for putting it there. And number 12. So we've practiced rewriting from exponential form to radical form. So you guys could do this one of two ways. I know your brains are probably telling you, because there's the power on the outside, to distribute that 1/5 in there. And we can make that 5 over 1, 30 over 1. So if you do that, you'll get 32 to the 1/5, m to the 5/5, and n to the 35th. So what happens then is you'll just have to rewrite that 32 in radical form. I just think this is a little more involved. I'll show you the other way to do it. The 5th root of 32, and m to the 5/5 is just m to the 1st, and n to the 35th is n to the 6th. Well, can you take the 5th root of 32? Yes, it is 2. So that will actually now be out there with your m and your n. So that's one way of doing it. You can distribute that exponent in, which in the past, your brain sort of always just tell you to do that first, and that is what order of operations tells you to do. But since we know how to write expressions with rational exponents in radical form, you can also, from the beginning, just start with that. Because if it's to the first power, it's almost like that power isn't there, but we can do the 5th root of everything. And now it's like the examples we just did, where you're going to find the 5th root of everything. So the 5th root of 32 is 2. 5 goes into 5 once. 5 goes into 30 6 times. And in this case, there's nothing left over. So both ways you guys could do that, sort of whichever one makes more sense to your one you think you might be more comfortable with doing.